Hello guys, welcome back to Mr. Cloudbook channel. Today is the day 22 of the Kubernetes masterclass, and in this video I am going to explain the Kubernetes stateful sets and why we need to use that, and we are going to see on a simple demo also. Okay, and let's go here. So we are going to talk about the stateful set here. Okay, so what we are going to talk about here is stateful set, and think of a classroom. So where each student has one desk. Okay, so this is one desk. Okay, and this is one guy, and we have so many people here. See, this is 3 and this is 4 and this is 5, and you can see anything. So many 6 desks are there here. Okay, for each student we have one desk, right? So this is one desk, and this is one desk, and this is one. So this is one. Okay, and what we will do is we will write each name. Okay, this guy like Alex. Okay, think like A, think this guy as a B. Okay, so this table as the C, and we will D. Okay, so what we will do is we will write each name on the student desk. Okay, so each student has also a personal notebook. Okay, see, this is the one notebook for student, and this is the student notebook. Okay, this is the student notebook. Okay, so we have each student has his own books, right? So here you can see that every student has their own notebook. Okay, so where they can write the important notes and everything. Okay, so every student has their own desk. Okay, so these two students, okay, this is one student and this is the other student. So these two guys have, okay, so what they have this desk. Okay, and they don't switch the desks with the other student. Okay, so what they will do, only these two, okay, these two people can sit in this one. Okay, so they don't allow the other students, or they don't switch the students with the other students. Okay, the desks or whatever the thing, they don't share with the other students. Okay, so every desk has the student name on it. So we will write the student name. So this guy name is Alex. Okay, something like that. This guy girl name is like some Ananya or whatever. So we will write. Okay, so if they leave for the lunch, okay, and come back, they know exactly which desk they want to sit, right? So if they went for the lunch and they again come back, okay, for the from the lunch, okay, they easily know, okay, I need to sit this one here only because this is my bench. Okay, these two students will sit on this first row bench, and these two students always sit on this particular bench, and this student here, and these two students from back bench. Okay, so each student has their own notebook. The notebook stays on their desk. If they leave and come back, they can continue where they left to. Okay. So even if this guy forgot his notebook, so this notebook will be here only. Okay. So but he can again easily find his notebook here. Okay. So he can write anything, or he can start anything that where he stopped. Okay, without any issue. So what happens when a student leaves and returns? Okay. If a student has to leave the classroom, like if they are sick or teacher ask them to leave, so no other students takes their desk. Okay, so when they come back, the students sit at the same desk with their name, so their notebook is still there. Okay, so they can pick up and write where they left. Okay, so what happened, this guy doing so much of noise. Okay, what teacher did, okay, you can go out of the class. So okay, what he will do, he will go out of the class for the whole period. This desk is not occupied by any other student, and his notebook will be stay here only. When period is complete, he come back again, and he will continue with the within the same desktop and within the same notebook. Okay, that is how it goes. Okay, so how is this like a stateful set? Okay, you are explaining about the students and classroom, but how it will matches the stateful set? Okay, so that is the question, right? You have. So here what we will do is, so now think of the stateful set as the system that controls how small computers, like see, so this is one my pod. Okay, this is one of my pod, and this is my another pod. Okay, here totally I have 3 pods. Okay, so they are all organized. Each pod is like a student with unique name. So this is like a student, this pod is like a student, think like that. So this has a unique name, that is one, and this is has the number 2, and this is has the number 3. Okay, so how it will work? Okay, this has the personal data. Okay, this pod has its own image, right? So we will create one image, right? Pod. Okay, and this goes another image. Okay, so like that, each of them has the different images. Okay, and different names also they will be provided. Okay, so they have own personal data and everything. This pod has its own data, and this pod has its own data, and this pod has its own data. Okay, so unique name. Okay, each pod has the unique name like pod 1, pod 2, pod 3, etc. These names never change. Okay, so just like the student names never change, so whenever this pod is crashed, okay, what happens? Sometimes the pod is crashed. Okay, so whenever the pod is crashed, even if it's restored or recreated, this name doesn't change. Okay, that is the main thing you have to understand. Where like the students also doesn't change names, right? Even if it's on sick leave, that name of the student is never changes like that. So here also, whenever the pod is crashed, the name of that particular stateful set pod is never changed. It will come back again with the same name. Okay, unique name. Okay, if pod, okay, stops working or restarts, okay, what happened? So here this pod is stopped. Okay, this one is get down. So what happened? So what we will do is, because we have some kind of mechanism, what it will do is it will always try to restart. Okay, so what we will do, we will try to restart this pod again. Okay, so we will restart it, and what happens here, so it will always returns to the same spot. Okay, so even if this particular, okay, this one is crashed and we try to restart it, and again it will come to the, if we restarted or recreated, it will come to the same spot. Okay, so whatever the, see, if student is on leave and if he came back again, so he will sit on the same bench. Okay, so this is the one bench, so here is one student and here is another student. Okay, so this student is on sick leave. Okay, so he didn't came to the class yesterday. Okay, so what happens if he comes today again? He will sit here only. Like that only. If a pod is restored or crashed, anything happens, so it will again came to the same spot here. Okay, that is the one thing we have to learn from the stateful set within the student classroom. Okay, and personal storage. Each pod has its own personal storage like student notebook. Okay, so this has the one storage. Okay, so we will create one storage for the each pod. Okay, and this one has its own storage. Okay, so I'm just using one, but here I'm just explaining like that. So each one has its own unique storage. Okay, so like the each student, so okay, this student has its own notebook. Okay, here, so what we can do is, this student has its own book, right? His class notebook or work notebook, and this student has its own book. Okay, so these two cannot use the same book, right? Like textbooks they can use, but his own notebook, okay, own storage, unique storage, can't be used by other student, right? So that is how it goes. So having the personal storage for the each pod in the stateful set. Okay, so to keep the important information, when the pod comes back, it still has its all old information. Okay, so this pod is crashed. Okay, okay, this has the unique storage here, right? So this is the unique storage for this pod. Okay, what we did, so that is down. Again it's create the new pod with the same unique name. Okay, with the same name. Okay, this is 3. So what it will do, it will again connect to this particular storage which is having its old information. Okay, so I have my old information here, so I can use it. Okay, so even if I restore, even if I take leave, even if I restore, recreate it again, so I will use my own unique storage, and I can take back the old information as well. Okay, so this is how stateful set works. Okay, stateful set has the unique name and fixed spot and the personal data. Okay, so why this is useful? Okay, why is stateful set is useful? Okay, sometimes a certain apps or a system needs to be remember things. Okay, so what happened? So this is a one app. Okay, this needs to be remember some certain things. Okay, so like I want to remember the database. Okay, here, so this application needs this database. Okay, so even if pod is crashed, okay, here this is crashed. Okay, so if again it's created the another pod, okay, with the same name 3, so again it will connect to this particular db, and where the process is stopped, it will again restart it from the that particular point. Okay, that is the use for the stateful set. Okay, so need to remember where they stored our information. So we need to know where we stored the information, or the pod needs to be know where the information is stored. Okay, So messaging system, we will use the stateful set in the messaging system and databases. And messaging systems like Kafka, RabbitMQ need to be remembered which messages they have already delivered. Okay. So if you redeliver, okay, see, I have this one. Okay. Here I have the RabbitMQ. Okay. RMQ. What happened? I delivered some messages. Okay. Here I delivered 170 messages here. Okay. 70. So what happened at that time? This pod is crashed. Okay. Again, it will create one more pod. Okay. Within the same name, same spot, and with the same storage. Okay. This is three. Okay. Sorry for that one. So if it's resent again the 70 messages, it will be like the spam. Okay. So this is not a good way. Okay. So where it will start from the 71 again instead of the 70. So in that format, we need the stateful set. So how this is different from the normal system, stateful set. So if you didn't use a stateful set, you would be using something called a deployment. Okay. In a deployment, the pods are the workers. Okay. Are like a students in a classroom where nobody has a fixed desk. Okay. So their student doesn't have any fixed desk. So they can sit anywhere. So if one student is not came, some student can sit that particular place. Okay. Students can sit at any desk every day. So they don't have any personal notebooks. So they want to start the fresh day. Okay. If his old notebook is gone, he need to restart the fresh one again. Okay. If student leaves, a different student might sit on that desk without any issues. Okay. This works fine if you don't care about the remembering the information. But for the things, okay. Sometimes I'm using my application. Okay. Here. So what happened? This pod is using one of the application. Okay. Four. Think like that. So this doesn't need anything. Okay. This is a simple front end application. Okay. But what happens is sometimes it's crashed. Okay, this doesn't care anything. Okay, no matter what, because it's not sending any kind of storage database. It's not storing unique information. No particular unique name also. Okay, even if it's crashed, okay, it will recreate. Okay, it does not impact anything. But if you are using the database, okay, are the messaging system. Okay, you need to remember the information. So you need the stateful set. Okay, you definitely need the stateful set at that particular point. Okay, a stateful set makes sure that each pod has a unique name, fixed spot, and their own storage memory, like a notebook with a notes. Okay, so this is useful for the systems that needs to be remember things like database, even if they restart without a stateful set. Pods would be like a students who can sit at any desk every day with no memory of where they sat or where they wrote the notes. Okay. Everything will be crashed. Okay. So whenever you use the database, okay, you would like to use the stateful set. Okay. So in a simple terms, I can explain. Okay. Here, what I will say, a stateful set runs a group pods and maintains a sticky identity for the each of those pods. Okay, this is a useful for the managing the application that need the persistent storage or a stable unique network identity. Okay, okay. Stateful set is the workload API project used to manage the stateful application. Stateful application which is used by the stateful set. Okay, which is the workload API object used to manage the stateful application, that is stateful set. Okay, which manages the deployments and scaling of a set of pods and provides the guarantee, okay, about the ordering and uniqueness of these pods. Okay, so what happens if you try to create a deployment? So what happened here? So I created the deployment with three replicas. Okay, it will get different kind of name. Okay, so some unique names you will get, like if you gave the name nginx, okay, n, okay, so at the end it will give some random, right? Like some UWXD like that. But here what happens in the stateful set, it will give like this. Okay. So if pod is created, it will give R0, okay, R1, like that. Within the simple unique names, it will provide. Okay. Even R0 is crashed here. Okay. Here R0 is crashed. Again, it creates with the R0. Okay. Not with the different name. That is the main point for the stateful set. Okay, which guarantees everything. Okay, it provides about the ordering and uniqueness of these pods. Okay, Like deployment, stateful set manages the pods that are based on the identical container spec. Unlike a deployment, a stateful set maintains the sticky identity. Okay, for each of its pods, these pods are created from the same spec, I mean specification, but are not interchangeable here. Okay, each has the persistent identifier that it maintains the across any rescheduling. Even if we restored, recreated everything, the name would be same. Okay, so if you want to use a storage volume to provide a persistent for your workload, you can use a stateful set as part of your solution. Although individual pods in a stateful set are susceptible to failure, the persistent pod identifiers make it easier to match the existing volumes to the new pods that replace that any failed pod. Okay, so even it's failed here. Okay, see the pod one is failed here. Okay, here this is failed. So it will stateful set what it will do, it will create again with the same unique name and it will attach to that particular existing volume. Okay, existing data. That is the main point here. Okay. So, however, many applications are stateful and require each instance to maintain its state between restores. Okay. So, this application, which application needs the database or some kind of messaging system should definitely use the stateful set. Okay. Here, S is mandatory. Stateful set. Okay. Stateful sets are valuable for applications that require one or more of the following. Okay. Stateful set has the stable and unique network identifiers, stable and the persistent storage, and ordered graceful deployment and scaling, and ordered automated rolling updates is also possible. Okay. So there are some limitations also for the stateful set. That is, the storage for a given pod must either be provisioned by the persistent volume. So we will talk about the persistent volume in the upcoming sessions based on the required storage class or pre-provisioned by the admin. Okay, that is the one of the limitation. And second one, deleting and scaling a stateful set down will not delete the volumes associated with the stateful set. This is done to ensure data safety, which is generally more valuable than the automatic purge of all related stateful resources. Okay. So even if it's down, it will keep the database back. Okay. Some limitations will be there. And stateful sets are currently require a headless service. Okay. Remember that stateful set is required a headless service to responsible for the network identity of the pods. Let's go to the demo for the stateful set, and I'm going to the Visual Studio Code here to write the simple stateful set.yaml. So most of the people don't understand this one because we are going to create a simple stateful set. So what I'll do is I'll just copy it from here. Okay. So this is the stateful set. So just copy it from here. I'm just copying it from here and I'll paste it here. And API version apps v1. If you don't know, you can come here. So let's see the nodes. kubectl get nodes. Okay. I'm using the killer coda. So kubectl explain stateful set, and you can see that here. So our group is apps and version is v1. So we have the group here for the stateful set. That's why we need to write the apps less v1 and kind is stateful set here. Okay. And the remaining are same here, and you can see that description stateful set represents a set of pods with consistent identities. Okay. Identities are defined as a network or the storage. Okay. Stateful set guarantees that a given network identity will always map to the same storage identity. Okay. So we have this one, kind is there, and the metadata spec we need to write. So we'll write it one by one. Okay. Let's go here. So metadata. So I'm going to use the Redis here. Okay. So Redis, because I'm going to use the simple Redis application, which is a very simple database, small one. So anyone can understand easily. That's why. So something we can't understand here properly. Okay. So because there may be some kind of issues here. Okay. So service name. So this is mandatory. Okay. So I'll just go with the Redis again. And app label should be also Redis. I will change everything to Redis. Okay. And you know, right, basically we use the spec and selector already in the deployments, and match labels. It should match that particular label. Okay. Here from this label. Okay. So service name is which is from the Redis. We will create a service, headless service for the stateful set. Okay, remember that. And the template metadata app as the match selector. Okay, so I'm going to use the Redis for everything. Yeah, simple one. I'm going to use the example directly. And the spec, we don't need this termination grace period. Okay, I don't want to use this one for now. So containers, everyone knows it. Let's change the name to Redis. So here everyone knows, right? Like this is also not needed. Replicas is enough. Okay, 3. And this is the image for your Redis application. I'm going to use the Redis 6.0. Okay, and by default Redis exposed to 6379, and the name is Redis. I'm going to use Redis again. And volume mounts, okay, this is the one name we have to remember, so you have to take care of these ones. Okay, so volume mounts you don't understand for now, because we will talk about in the PV and PVC, persistent volumes and persistent claims. Okay, so but simply we will use this one. Okay, so mount path is data, and volume claim template also the name. Again you need to use the data. Okay, so because we're using the name here. Okay, data. Okay. And access modes, we will use the read write ones, and storage class name should be standard. I'm going to use, so we will talk about in PVC. Okay, standard and resources, yeah, this is fine. So this is the simple Redis stateful set. Okay, and we need a simple service also, headless one, svc dot yaml. Let's go and write these services. Okay, just copy this service. So I'm in the service section. Okay, paste it here. And which service you need, name of the service, you can use the simple Redis one. Okay, by default, because we are using the same names, right, for everywhere. Okay, Redis service, Redis, and selector we use the app Redis, app equals to this is Redis. Okay, so because we use it the selector here, you can see that match label app is Redis, right? That's why I'm using the service is Redis. And the name, we don't need this for now. We can close it. We will write inside. So here spec section I will change a little bit. Okay, ports. Okay, so port by default in, I mean, Redis exposure to 6379, and the name Redis. Okay, and next we need to write the cluster IP. Cluster IP. Okay, so none. Okay, why we are using none means it will create the headless service. Okay, and next we need to write the selector. So which selector we are going to use this service, app Redis. Okay, for that one we are going to create the service. Okay, we already talked about it, right? Stateful set needs the persistent value, right? Let's create a persistent value. Okay, so let's come back here. So everything is here only, so, but I will take the examples. Okay, but for now you have to understand what is the use of the stateful set, but we will use understand everything persistent volumes in the upcoming videos. Okay, so let's go down little bit. So this is the simple persistent volume. Right click, copy it. I'll create it here. Okay, pv.yaml. I mean like simple persistent volume. Okay, enter, paste it here. So if you don't know, again you can come back here. Okay, everything is provided here. Clear the screen. So kubectl explain PV, but no need to worry about the persistent volumes for now. I will explain more detail way. Version 1 and persistent volume. So I used it the same thing here. And name, metadata, these are all same. Okay, so let's give the name as the Redis -pv. And capacity, how much you are asking here? 1 GI. Okay, same thing we will ask here also. So we need the 1 GI. Okay, 1 GI. And volume mode, we don't need to use it. Okay, remove it. And access modes, read write ones, and here is also we are using read write one. Okay, persistent value, so read write ones. And persistent volume reclaim policy, retain. Okay, use retain and recycle, I will talk about it later. Why we are using retain means whenever the pod is crashed, it uses again, if new pod is created, it will use this particular volume, okay, persistent volume. And storage class name. So what we used here, storage class name is standard, right? So just copy this and paste it here. Okay. So same thing we are using inside the stateful set, that is we are using as the PV. Okay. Host path also we need to write. Okay. Host capital P path and come down and we have to see the path here. So what is the path? Slash data slash mnt slash data. Okay. So these are the three we need stateful set. Okay. So these are all values, volume mount values comes from the PV. So no need to worry about it. And the remaining this is like a simple deployment file only. Okay. So let's copy one by one and I'll paste it here and clear the screen. So vi sf.yaml, paste it, apply it. Okay. Oh, sorry. And vi svc.yaml, I'll create all files here. Service.yaml, headless service. So we are using none means headless service, okay? And come out of it. And finally, persistent volumes, copy it. Vi pv.yaml and come out of it. Okay. So let's come out of it and kubectl apply -f sf.yaml. First I applied the Redis stateful set and next I'll apply svc.yaml service. Finally, I'll apply fpv.yaml. Okay. It's created all. Let's see. kubectl get PV persistent volumes. We have one that is Redis PV we created and it's still available. Okay. It's not taken by anything. And service. And we created the Redis service that is none means headless service. Okay. 20 seconds ago. And kubectl get stateful set. Okay. And you can see that still not ready yet. Okay. So it will take some time. kubectl get pods, but you can see uniqueness here. Okay. You can see that Redis 0, Redis 1, and it will create in a different format. Okay. So each will take some time to create these. Okay. kubectl get pods. So you can see unique name it will get always Redis 0, Redis 1, Redis 2, Redis 3 like that. So unique name is there. And if you describe it, okay. So kubectl describe pod and paste that pod. Okay. And you can say that it uses the default one. Okay. You can see that pod has the unbound immediate persistent volume. It will use the persistent volume claims. Okay. And you can see it from here also, like what is it using? Ready state, true, which mount it's using, data. We added this one, right? Okay. It is screen. And you can see the pods again. So it's taking one by one. No worries because we have this one, right? Automatically. That is no problem. So what I'll do is I'll do into it exec. Okay. -it Redis 0 hyphen Redis -cli. Okay. So I'm inside the Redis CLI here. Okay. So what I will do is I will set one value. Okay. Set my key. I will set is the hello. Welcome to Mr. Cloudbook and thanks. Okay. So this is the simple key I set. Okay. You can see that it said okay. Okay. What I'll do is I'll exit from here. Let's see the pods again. So one is deleted. What I'll do is I'll delete this one. Okay. Copy it. I'll delete that pod. Okay. kubectl delete pod and paste it. You can see that Redis pod is deleted. Okay. 0 and get pod. And you can see that it's again created the Redis 0. Okay. See 4 seconds ago. So it creates with the same unique name. Okay. What I'll do is I will again go inside again. Okay. Exec into that one. So I don't add anything here. Okay. Let me clear the screen. What I'll do is I'll just use get my key. Okay, it will give my old data. You can see that it's using my old data. What I explained in the explanation also the same thing, right? So whatever the thing happened, okay. So I'll set another one. Okay, set. So this is like a key value. Ajay Kumar. Okay, simple. I added this one and okay. So what I did is I'll come out of it. Okay, exit. Sorry, not here. Exit. So I'll delete the pod again. Okay, kubectl. First of all, see the pods. Okay, 57 seconds ago. I'll delete again. Okay, you can see that it's deleted here. Clearly, you can see Redis 0 is deleted. What I'll do is I'll see again pods and it will create again every time with a unique name. And if I exec into the same pod again, Redis CLI, clear the screen, get key, Ajay Kumar, get my key. So these are all old values. Okay, even if pod is deleted, it's taking the old information. That is how stateful set works. Okay. And I hope you understand the video about the stateful set. I know little bit confusion because of there is an PV is added here. That's why you will understand once the persistent volumes is completed. Okay. Thanks for watching the video and keep on supporting to Mr. Cloudbook channel.